This is a follow-up to a video that I did on using Strava data to measure the delays caused by Westconnex detours. There are problems with using Strava data for this sort of thing, so I want to show how I would do this in an ideal world. To understand this video, you really need to watch the previous one first. For starters, only a small proportion of all cyclists bother to use a fitness app like Strava. I tried to get a feel for this by using the Strava flyby feature. This shows you every other Strava user that you went past during a particular activity. I chose the 3rd of May. Because it was a nice sunny day, there were lots of people on the Bay Run, and I still had video from that ride on my hard drive. When I turned on Flyby, I found I had gone past 7 other Strava cyclists, and I filtered it to rides only. I then went back to the video and counted how many cyclists I went past on the Bay Run. It turned out I went past 84 cyclists in total, 28 kids and 56 adults. I separated out the kids and just focused on the adults. From this sample, only 12.5% of adult cyclists were using Strava. Of course, this is a sample size of 1, which isn't very significant. I'd need to analyse a lot more rides to gather more data, but right now, I don't have the time or the patience. Let's just work with 1 in 8 or 12.5%. This gives us an idea of how limited our overall set of data is going to be. Let's revisit the graph that I created previously, showing the spread of ride times before the detour and after the detour. The blue line shows the distribution of fastest times for each rider before the detour, and the orange line the spread of fastest ride times after the detour. Ideally, we would start with a graph like this for every cyclist who has regularly ridden over the Anzac Bridge. This is what my spread of times looks like over 504 different days. This is just one direction. You can see every ride from the fastest to the slowest and everything in between, and we end up with a bell curve with a long tail to the right. From this point on, we're using dummy data because I don't have the real thing, but this is what I would like to do if I could get my hands on the real data from Strava. Instead of just having one bell curve of data for me, we'd have one bell curve for every single cyclist, maybe even over 8,000 individual bell curves. That would look like a real mess, so let's just imagine what the bell curves for 6 cyclists would look like. There would be a spread of curves with different medians and different standard deviations. That is, some would be tall and skinny, others would be short and fat. There'd be a multitude of shapes. This data is buried in the Strava database, and we can't see it. Instead, what we see are the red dots on the far left of each bell curve, the fastest times for each rider. Instead of having maybe 500 data points per rider to work with, we only have 1. This next graph also uses dummy data, but it shows the next thing that I would like to have for every cyclist. Data from before the detour went in and data from afterwards. For every rider that regularly rides over the Anzac Bridge would have 2 curves, before and after. Note that the shape of each curve would probably be quite different due to the variable impact of traffic lights and any works that have been carried out along the detour on your transit times. These red lines show how the median has shifted from before the detour to after the detour for this individual rider. Purple arrows show how the standard deviation has widened as well. Now, if we had all this data, what we would end up with is something like this. 2 sets of curves for every single cyclist. Here is where the fun begins. For each cyclist, I'd calculate their median time from before the detour and compare it to their median time from after the detour, and I'd put the difference into a table. For example, for cyclist A, their no detour median time was 210 seconds and their post-detour median time was 350 seconds, giving a difference of 140 seconds. Once all these values are put into a table, you can group them and count how frequently each value appears. This, I think, would give a better indicator of how Strava's users are being impacted by the detour. We could do the same for the standard deviations, but I can't be bothered creating another chart to illustrate that. But it's what I would do if I had the data. Now, there are some pitfalls with this more detailed approach. Firstly, only around 600 Strava users have cycled over the Anzac Bridge since the detour started, as opposed to over 8,000 who cycled over the bridge in the years prior to the detour being put in place. This means that out of all our Strava users, at best, we will only have comparative data for around 11%. And even then, I wouldn't guarantee that everyone who has cycled since the detour cycled through here prior to March. so that would even further reduce the pool of cyclist data that we can analyse. The other problem is a possible lack of post-detour rides due to the lockdown. Normally, I would have ridden into town at least 24 times since the detour started. I usually go to work twice a week. Well, I go into the office twice a week. But I've only done it 5 times because I've been working from home full-time since the lockdown started. I suspect that's the case for a lot of other cyclists. So whilst for me there are over 500 pre-detour data points, there are only 5 post-detour data points. If you ask me, that's not sufficient. But you know what? All of this is better than nothing, or operating by pure guesswork and conjecture with no collection and analysis of any data whatsoever.